Start with the unit circle itself. It's a circle centered at the origin with radius 1, so every point on it satisfies x squared plus y squared equals 1. Nothing trigonometric yet, just geometry. Now fix an angle. Place its initial side on the positive x-axis, then rotate by an amount theta. Counterclockwise is positive, clockwise is negative. That rotation hits the unit circle at exactly 1 point. Call that point P with coordinates x, y. The key idea is simple and absolute. The angle chooses the point. Here is the definition. If the terminal side of theta meets the unit circle at P equals x, y, then cosine of theta equals x and sine of theta equals y. That is not a result. That is the definition. Every other fact about sine and cosine comes from this sentence. Because every point on the unit circle has coordinates between -1 and 1, sine and cosine are always between -1 and 1. Because rotation works for any real number, sine and cosine are defined for every real angle, not just acute ones. Negative values are no longer strange. They are just negative coordinates. Now connect this back to triangles. In the first quadrant, drop a perpendicular from P to the x-axis. You get a right triangle with hypotenuse 1, adjacent side x, and opposite side y. So cosine is adjacent over 1, which is x, and sine is opposite over 1, which is y. Right triangle trig wasn't wrong. The unit circle just extends it beyond where triangles exist. Tangent follows immediately. Tangent of theta is sine over cosine, which is y over x. Geometrically, that is the slope of the line from the origin to P. When x is 0, that slope is undefined, and so is tangent. You can see the asymptotes directly on the circle. The most important identity drops straight out of the geometry. Every point on the unit circle satisfies x squared plus y squared equals 1. Replace x with cosine theta and y with sine theta. You get cosine squared theta plus sine squared theta equals 1. This identity is just the equation of the circle written in trig language. Sines no longer need memorizing. Cosine is the x-coordinate, sine is the y-coordinate. Look at the quadrant and the signs are obvious. Tangent sine follows from the ratio. Symmetry gives angle identities for free. Reflecting a point across the x-axis changes y but not x, so sine of negative theta is negative sine theta, while cosine of negative theta is cosine theta. A half turn through the origin flips both signs. These are geometric facts, not algebra tricks. Radians fit here naturally. On the unit circle, the radian measure of an angle equals the arc length. One full loop has length 2 pi, so adding 2 pi brings you back to the same point. That is why sine and cosine repeat every 2 pi. Finally, let the point move. As theta increases, track the y-coordinate and you get the sine graph. Track the x-coordinate and you get the cosine graph. The wave shape, the bounds, and the period all come from circular motion. Everything reduces to one sentence. An angle determines a point on the unit circle, and the coordinates of that point define trigonometry.